Assalamualaikum and hi everyone. In this video, we will discuss about Thermochemistry, the second chapter of SK025. In this chapter, there are 4 subtopics which are concept of enthalpy, calorimetry, Hess's law, and finally the Born-Haber cycle. But in this video, I just want to focus on 2.1, the concept of enthalpy. In this subtopic, what you have to know is, the first one, you have to explain endothermic and exothermic reactions using the complete diagram. The second one is, you have to state standard condition of reaction and define the following terms. The first one, enthalpy, and the second one is standard enthalpy. And lastly, you have to define and write thermochemical equation for each enthalpy below. The first one, formation, combustion, neutralisation, hydration, and finally the enthalpy of solution. There are some important terms in this thermochemistry subtopic, which is heat, system, and surrounding. Heat is energy transferred between two bodies of different temperatures, where the transferring of energy happens from hot bodies to cold bodies. The second one is about the system, which is any specific part of the universe that we wish to observe on its changes. We have open system, we have closed systems, and we also have isolated system. And the third one is about the surrounding, the everything that lies outside the system. You can see from the diagram, the surrounding is outside the system. First, we will look at the energy profile diagram for us to explain about the endothermic and exothermic reaction. As you can see from this diagram, it is an endothermic reaction, which enthalpy of reaction is positive value, which explain that the process absorbs energy from the surrounding to the system and results in increase in the enthalpy of the system. So we can have the enthalpy of product is greater than enthalpy of reactant. That's why the shape of curve of this endothermic reaction is product will be higher than the reactant. Second energy profile diagram is about the exothermic reaction with delta H negative value. It process that release energy from the system to surrounding, which results in a decrease in the enthalpy of system. So enthalpy of the reactants is greater than enthalpy of the product. Another term that is very important in this topic is about the term standard enthalpy. The standard term here refer to the enthalpy change measured at standard condition, which is 298 Kelvin or 25 degrees Celsius and with pressure of 1 atm. Next, you will learn about the thermochemical equation. It is a chemical equation that shows the enthalpy changes. You already know that this is kind of chemical equation, but when it comes with the enthalpy change or delta H, so we call it as thermochemical equation. As we know, if the enthalpy change is positive, so it is an endothermic reaction, while for the second example is the thermochemical equation of exothermic reaction, as it has negative value of enthalpy. There are some important aspects in thermochemical equation. The first one is about the sign, positive or negative. For example, I have this thermochemical equation with delta H equal to positive 572 kilojoule. It indicates that this reaction is an endothermic reaction. But when I reverse the reaction, I change the position of reactant and product, so it becomes 2H2 gas plus O2 gas produce 2H2O, which is reversed from the first equation. What happened with the sign of delta H here is it has changed to negative sign. So it has become exothermic reaction. The second aspect is about the magnitude which is we can relate with the stoichiometrical of the equation. For example, I have 2H2 gas plus O2 gas produce 2H2O liquid with delta H is equal to negative 572 kilojoule. Now, I change the equation which I make it half. So, I have second equation H2 gas plus half O2 plus H2O. So, what will happen to the delta H here is it will also become half from the first equation. So, what we can say here is the stoichiometrical relationship will affect the value of delta H. Next, we will learn about the types of enthalpy. There are 6 types of enthalpy, which is formation, combustion, atomization, neutralisation, hydration, and also solution. Let's learn how to define the enthalpy of formation. So, if you can see from this table, I have separate the term of enthalpy, heat change, release or absorb, and 1 mole, because that is the terms that you have to consider to define the types of enthalpy. So, how to define the enthalpy of formation? Enthalpy of formation with the symbol of delta HF is the heat change. It is heat change means it can be negative or it can be positive value. When 1 mole of compound is formed from its elements in their most stable states at standard condition. Take note about the words elements. For example, the formation of H2O. This is the one that we are going to form. So from the definition, we have to make sure that in the thermochemical equation, H2O must be 1 mole. It is formed from its elements. Now, H2O, we have hydrogen and oxygen. But hydrogen, it exists as H2 element. H2 is the most stable state of hydrogen. So, H2 gas plus O2 gas. O2 is also the most stable state of oxygen. So, we plus O2 gas. But to make sure that H2O is equal to 1 mole, so we have to make the O2 as half into this equation. So this is thermochemical equation for the formation of H2O. Let's see another example. This is carbon dioxide. This is the one that we are going to form. So in carbon dioxide, we have carbon and oxygen. And we have to identify carbon exists as carbon graphite or solid as its most stable state, while O exists as O2 gas as its most stable state. So, we have to add C plus O2 gas to produce CO2. In this thermochemical equation, 1 mole CO2 is already balanced with 1 mole of carbon and 1 mole of oxygen. So, this is the thermochemical equation for the enthalpy of formation of carbon dioxide. Next, we will go to enthalpy of combustion. It is heat release. Heat release here means enthalpy or delta H is negative when 1 mole of substance completely combusted in oxygen gas. In other words, we can say that oxygen gas in excess. This is an example of thermochemical equation for combustion. The 1 mole must be for carbon because carbon is the one that are going to undergo combustion plus oxygen gas and it will produce CO2 gas. In this equation, the 1 mole must be for carbon. So we have to balance the thermochemical equation so that the carbon is 1 mole. So this is a balanced one, and with the enthalpy of combustion stated here, so this is the thermochemical equation for enthalpy of combustion. Next is about the enthalpy of atomization. It is heat absorbed. Heat absorbed means delta H is positive. 1 mole of gaseous atoms is formed from its element. So let's see the example. Na solid, sodium solid, is the element of sodium, and sodium gas is the gas atom that is going to be formed from the element. So the equation will be Na solid to produce Na gas. 1 mole must be at the product because it is the one that we are going to form. Let's look at another example. Gas atom that we are going to form is chlorine gas. Element of chlorine is Cl2 gas. For this equation, we have to balance so that the gas atom must be 1 mole. That's why we will put half at Cl2 gas in the equation. So, with the value of delta H equal to positive 1 to 1 kilojoule per mole, this equation is called as a thermochemical equation for atomization of chlorine. Next is enthalpy of neutralisation. Heat release, delta H will be negative when 1 mole of water is formed, when acid reacts with base. So the word 1 mole is stand for water. Let's see the example. This is acid, this is base, so it will produce salt and water. So the one that must be 1 mole here is this water. So we have to balance the equation so that H2O is stay as 1 mole. In this equation, all the stoichiometry is already balanced with 1 mole, and we also get 1 mole of water. And with the value of delta H here, this is what we call as thermochemical equation of neutralisation. Okay, let's look at another example. We have HNO3 as acid, BaOH2 as our base, so it will produce salt and water. In this case, we have to balance so that H2O become 1 mole. That's why we have to put half for BaOH2, barium hydroxide, half for barium nitrate. By referring to the definition, 1 mole of water is formed when acid react with base. So the next enthalpy is enthalpy of hydration. It is heat release. Heat release, the delta H will be negative when 1 mole of gaseous ion in phase of gas is hydrated in aqueous solution. Let's look at the example. So the gaseous ion, Na plus is an ion in the gas phase, and it is hydrated in aqueous solution to form Na plus aqueous. So for the hydration, it is from gaseous ion to aqueous ion. This is the one that we call as thermochemical equation for enthalpy of hydration of Na plus gas. And finally, enthalpy of solution is heat change. When heat change means it can be positive and it can also be negative value. When 1 mole of a substance dissolves in solvent, which is water, to form an infinite dilute solution. For example, KCl solid. KCl solid or potassium chloride is the substance that are going to dissolve in water. So this potassium chloride will dissolve in water. The 1 mole must be for KCl. This one must be 1 mole because it is the substance that are going to be dissolved in solvent. For the KCl solid, when it dissolves in water, it will form KCl aqueous. So actually KCl aqueous, it is in the form of K plus aqueous and Cl minus aqueous. This one we call it as thermochemical equation involving the enthalpy of solution of potassium chloride. All of this definition will be used when we want to perform our calculation because it will be related to the stoichiometry of the equation. That's why I stress of 1 mole here. So you have to make sure or notice which substance or which component in the equation must be 1 mole. This definition is also will be used in the Born-Haber cycle, the last part in this subtopics. That's all for this video. Do you have any question? If you have question, you may leave a comment on Submit or ask your lecturer immediately. Thank you.